Hello, welcome to study our course called Native Architecture. In this lesson 23, we will study the Kubernetes component interaction, and we will use factory analog to the Kubernetes. So here we just there as we studied before, there are the workloads. So there were two workloads and one master loads. We can here use this analog to a factory A, and this is factory analog to factory B, and this is the master load analog to headquarter, and here just the apps one they are both in workload in the factory A, and in the factory B, we can analog they are responsible for producing cars, and this app 2, they are in the three loads. They are both in the workload, two workloads and master loads. Normally we don't put the workload in the master load. Okay, but the workload could be put in the master load, and the app 3, we analog the app 3 is are responsible for producing planes. Okay, all the apps are containerized service, so they are dependent of the container runtime. So we have to install the container runtime in each load. And here the Kubernetes. Kubernetes, they are responsible for start, stop, or restart the apps. So we could analog the Kubernetes to the factory manager. They are they can monitor the producing of such as the producing of this cars or producing of the planes. Okay, so this is the Kubernetes. We can consider it as the factory manager, and here the manager can start the app 2 in this factory A. Okay, if the load this apps is fault, so he should detect and monitor the health of the apps, and he could respond and report the health status to the API server. We could consider the API server as a secretary. So was a component interact with the master load through the API server through the secretary. Okay, and the secretary API server will pass the information to the controller manager. We can consider that consider the controller manager as the CEO of this factory. Okay, and they will put all this data to store in the etcd k8s store. Okay, so all the important design information will be stored in the etcd k8s store. Okay, and here if now the CEO now has known that the factory A is not suitable for producing the such as the F2 is responsible for producing glass. So he told the information to the schedulers through the API server, through the secretary. This scheduler now consider the actual fact of these two factory, and now he think the factory B here. I think the factory B could reproducing the glass. So he also part the interaction, the information, design information should be stored in the etcd k8s store and through the API server. Okay, and now the secretary told the factory manager, in your factory you should producing the glass such as F2. Okay, now the factory managers receive this information and start producing the glass. Okay, here, and it tends to be green. Okay, now was the workload distributed in different factory in the workload, and they are so they were can be accessed by the kube proxy. We consider it as the guard. So if you want to access the other app, they must first wait should wait the guard, and the guard will tell the address of this app here. Okay, yeah, if the F2, F1, such as the producing the cars, want to visit the factory, the composite apps producing planes. So first it should ask the guard kube proxy. Okay, and the kube proxy guard knows the address and location of the apps. So he know, okay, the app3 are located located in both workload A and workload B, and okay. So now the F1 can access the F3 and know the exactly address. Okay. So here we know the kubectl is a client command, because the real decision maker is the kubectl. It is controlled by the programmer. So if the programmer want to interact with the cluster, Kubernetes cluster, so it is so the kubectl command interact with the secretary API server, such as we want to let the Kubernetes to create a Nginx image. So he just can use the kubectl command and pass to the secretary, the API server, and the API server told the controller manager, okay, this is the whole process of the Kubernetes component interaction in this animation. So that's all. Thank you.